Good morning, dear students. Hope you all are safe. Let's make this quarantine into a beneficial one. Today, we are going to learn Science Term 1, Lesson 1. Today's topic is about measurement. So, here in this session, we are going to learn some basics about SI units, what are base quantities and their units, and also we will study about temperature, luminous intensity, electric current, and amount of substance. This will give you a knowledge of accuracy in measurement. Let's get into the topic. So, what is measurement is a usual question. Why do we need measurement? Have you ever thought of measuring the length of your pen or the notebook you write? Thus, measurement is going to be the base of all the experiments. Measurement helps you to find some quantity which is unknown to you. When you are experimenting to find the length of the notebook, length is the physical quantity which you are finding. So, how are we going to find this length? For a perfect measurement, we need three things. They are an instrument, a standard quantity, and an acceptable unit. For example, if you want to find the length of the mobile phone or the laptop with which you study, you can measure it with a normal ruler and you find it to be 10 or 20 centimeters. So here, ruler is the instrument with which you find the length and 10 or 20 centimeter is the standard quantity of length and centimeter is the unit of length. Now let's see some system of units. You have FPS, CGS and MKS. FPS stands for foot pound second, CGS stands for centimeter gram second, MKS stands for meter kilogram second. So you can see that all the three are going to give me the same three quantities. They are length, mass and time but in different names. These three quantities was earlier used as a system of units. But later in 1960, International System of Units was introduced, which is commonly known as the SI unit. Under this SI unit, you have 7 basic quantities which are known as the standard quantity and their units known as the basic units. So what are these 7 quantities? Here you have the 7 quantities. Under this, length, mass and time are something which we have already learnt. Now let us explore the new terms. Let's see them one by one. The first one is about temperature. Have a look at the pictures. You see an ice cream and a fire. You can say that ice cream is cold and fire is hot. How do you say it's either hot or cold? You need some quantity to decide the hotness or the coldness of a substance. That is called temperature. So how can I define it? Temperature is the average measure of kinetic energy of particles in a system. The SI unit of temperature is Kelvin. How do we measure it? Thermometer is an instrument which is used to measure temperature. These thermometers are usually calibrated in 3 standard scales. They are Celsius scale, Fahrenheit scale and Kelvin scale. These 3 thermometers have 2 fixed points. They are the lower fixed point, which usually refers to the melting point of ice, and the upper fixed point, which refers to the boiling point of water. Now let's see deep about this. Here you have the 3 scales of thermometers. As discussed earlier, you can find from the picture the lower fixed point and the upper fixed point. In Fahrenheit scale, the lower fixed point is 32 degree Fahrenheit and upper fixed point is 212 degree Fahrenheit. Likewise, you find in Celsius scale and Kelvin scale the lower fixed point and the upper fixed points. The next is, how are we going to convert from one scale to another? For this, have a look at the picture again. You can find the difference in scale, that is, the difference between the upper fixed point and the lower fixed point in each scale. This difference in Fahrenheit scale is going to be 180 degree Fahrenheit. That is 212 degree Fahrenheit minus 32 degree Fahrenheit is what is called the difference. Likewise, in Celsius scale and Kelvin scale, this difference is found to be 100. So what are we going to do with this difference? With this difference, you can easily convert from one scale to another. So the general formula for conversion is given as f minus 32 by 180, c minus 0 by 100, k minus 273 by 100. Applications. Thermometers are used to find the body temperature. For this, Fahrenheit scale thermometers are used. Scientists in laboratories use thermometers in Kelvin scales. To find out the weather condition and the room temperature, Celsius scale thermometers are used. Next is electric current. Have a look at the picture. Here in this image you can see the free electrons, which are simply called as the charges. They are moving in a conductor AB in a particular direction. That is, they are moving from A to B. This is what is called electric current. So how can I define it? An electric current is a measure of rate of flow of electric charge through a conductor for a given period of time. Therefore, it can also be expressed as I is equal to Q by T, where I refers your electric current, Q is the charge flowing, and T is the time taken. The SI unit of charge is coulomb, the SI unit of time is second, and therefore the SI unit of electric current is ampere. In place of Q, if I take 1 coulomb of charge, and in place of T, if I take 1 second, then I get electric current to be equal to 1 ampere. So that is how 1 ampere is defined. It is defined as 1 coulomb of charge moving in a conductor in 1 second. Electric current is measured using an instrument called ammeter. The next topic is about amount of substance. Each and every object or substance is made up of atoms and molecules. These atoms, molecules, ions are called as entities. Have a look at the picture. Here you see the picture of common salt, that is NaCl, which we use in our home. Now, if I want to focus upon one particular crystal in this salt, this is how it looks. So you can see one single crystal is made up of sodium atoms and chlorine atoms. Thus, a measure of number of entities, that is the atoms or molecules present in a substance, is called amount of substance. The SI unit of this is mole, which is commonly referred as MOL, mole. In general, a mole is defined as the amount of substance which contains 6.023 into 10 power 23 number of entities. This number is also known as the Avogadro's number, which is something important to be noted. The next topic is about luminous intensity. Most of us would have been to a photo studio, or we would have watched a cricket match on TV. There you find the umpire checking for the visibility of light in the ground. What is he doing? He is actually checking the luminous intensity. So luminous refers to light. Intensity refers to the particular direction through which the light travels. In this image, you can see the source, which is the bulb, which emits the radiation on a particular surface area, and then the light which is reflected to the human eye. So luminous intensity is the measure of light emitted by the source in a particular direction as it is perceived by the human eye. The SI unit of this luminous intensity is candela, which is represented as CD. It is measured using an instrument called photometer. So children, let's have a short recap. Today's class we learned why do we need measurement, and we also saw some base quantities and their units. We learned about temperature and the instrument to measure and the unit of temperature as Kelvin. We learned what is electric current, and we also learned the measurement of it and the unit as ampere. We saw about the amount of substance, the measurement of it, and the unit mole. We also had an idea what is luminous intensity, how it is measured, and the unit to be candela. Children, I hope you're clear with this. If you have any doubts, kindly ask me. Thank you.